Hi, I thought we'd start this lesson with an image of some of the complex igneous rocks that we find on the Isle of Rum off the west coast of Scotland. It's an incredible geological wonderland. If you want to learn about igneous rocks in real detail to see what's going on deep within the earth, Rum really is the place to go. Anyway, the reason I've shown this is because we're getting towards the end of theme 5. What we need to do now is start putting all of these ideas together. So we're working on page 18 of our theme 5 booklets. Let's go. I've given you two pieces of data here. We've got some polished sections of rock showing us their mineralogy, showing us their texture. And we've also then got a cross section through a cliff with lots of igneous features shown. I should perhaps have updated this particular diagram. Batholith there is actually a pluton. Okay, it's an old-fashioned word for a pluton. Okay, what I'd like you to do is have a go at the questions on page 18. You may want to look back at the work we've been doing throughout theme 5. Let's see as well if we can use as much of the correct geological language as possible. Okay, so press pause and have a go at that now. Let's change that diagram. Okay then, let's see what you've come up with. Let's start by looking at these two rock specimens, rock B and rock C. The first question I asked was what the similarities between them. They're both igneous rocks, so we both see randomly oriented crystals. We both see as well that they're interlocking crystals. And the reasons for that is that these rocks have cooled from a melt. Also, both of these rocks are coarse-grained. They both have crystals greater than 3 millimeters. And the reason for that is because these have both cooled slowly. Question B asks for the differences. There are two key differences here. Firstly, in the composition, in the minerals that are in the rock. B is a mafic igneous rock, and we can tell that because it contains olivine. Olivine makes that mafic. Augite as well suggests mafic as well, but olivine is the key mineral. C, on the other hand, is silicic. And the way I can tell it's silicic is because it contains quartz and also orthoclase feldspar. But quartz there is the key mineral that tells us it's silicic. The reason for that is that these have cooled from different magmas, perhaps in different plate tectonic settings. But that's for theme 7. The other big difference between these two is the texture. The size of the crystals and the way those crystals are put together. B we describe as being equicrystalline. The crystals there are all about the same size. That's because that rock has cooled at a steady rate. A slow, steady rate gives us a coarse equicrystalline texture. Rock C, on the other hand, is porphyritic. We've got some very large crystals, the orthoclase feldspar, that have grown and made these really well-shaped crystals, nice straight sides there. And then surrounded by a ground mass of smaller crystals, it makes this porphyritic. And the reason for this texture is we've got two stages of cooling. A very slow stage for the orthoclase feldspar to cool and crystallize, and then a slightly quicker stage which leads to the quartz and the biotite mica crystallizing. Question C then. I asked to name these rocks. Rock B is a gabbro. Rock C is a granite. And we know that because they're both coarse-grained, but B is mafic, C is silicic. Check your classification of igneous rocks table right at the start of theme 5 if you need to check that. Okay, the next questions then were related to this diagram of a cliff. I asked you to identify the different features that are in here. P is a lava flow, and we can tell that because we've got a bake margin just at the bottom of P. Q is a dike. It's sheet-like, so it's quite thin. We've got bake margins both sides, and they cut across the country rock there. R is a sill. We've got an igneous body here that follows the beds. It's concordant with the bed, with the beds in the country rock, and we've got bake margins top and bottom. And finally, S is a pluton, large igneous body that cuts across the other beds. Now, those of you that dug a little deeper into this, I asked you to identify any other features. We have some xenoliths here, some bits of country rock that have fallen into the igneous rock. I'd hope most of you would get that. There are some other features here though. There's a zone of metamorphism around the pluton. Now, we're going to talk about this more in theme 6. It's a feature we call the metamorphic aureole. We can also see, if we look really carefully, the beds here are actually displaced. They're moved along the crack that's now been filled up with the dike. This is something we call a fault. More about that in theme 13. Okay. Okay. What I'd like you to do now is to have a go at question 9. So the first part of the homework. Now, question 9 is looking at the different types of rocks that you need to be able to recognise. And crucially, I want you to think about this word texture. Okay? Texture in geology is all about the size of crystals, or the size of grains, and how they relate to each other. It is not to do with how a rock feels. Okay? Texture has a very specific meaning in geology. So when we're answering question 9, I want you to use the correct terms for texture. Now, the words I'd like you to use are these. These are how we describe the texture of igneous rocks. Not other types of rocks, this is just igneous ones. So use these words to help you answer question 9. There are some other features as well we can put in there. It's composition, whether it's mafic. Rocks like basalt, dolerite, gabbro are all mafic. Whether it's intermediate, andesite is intermediate rock. Whether it's silicic, like a granite. So use those words in question 9. Okay. We could also talk about some of the other features that we see there, like density, colour, but it's really the texture and words to the composition that matter. Okay then. As we watch the sunset over the island of Rum, we can put together now all of the ideas we've looked at about igneous rocks, the types of igneous rocks and the bodies that they form in. Next time we'll tie up the last bits of theme 5. I'll see you then.